Hey everyone, Reese here, and welcome to another Docember episode of Control-Alt-Reese. And if you're not familiar with the concept of Docember yet, it's basically a group of retro computing YouTubers all working together to put out videos on the theme of DOS throughout the month of December. I will link to the official playlist down in the description and also the list of participating channels, and I also urge you to check out the Docember hashtag. So for this final Docember video, I thought I'd go right back to DOS's roots, and the machine that launched with PC-DOS 1.0, which was of course the collaboration between IBM and Microsoft, and which grew into the MS-DOS which we all know and love. I'm talking of course about the IBM 5150, and more specifically, my IBM 5150, and the upgrades and modifications that I've done to it, including the graphics and the sound, getting it hooked up to my home network and the internet, and even a DIY overclocking solution. And these are all things that make this machine really fun and easy to use, even as it enters its 40th year. The iconic IBM 5150 personal computer. Released in 1981, this simple beige box, built around unremarkable off-the-shelf components, would go on to revolutionise desktop computing, shaping its direction for the next 40 years, and counting, for better or worse. In fact, if you're watching this video on a laptop or desktop and it's not one of those fancy new ARM-based Apple devices or Chromebooks, it's probably safe to say that you're watching on a direct descendant of this very machine. Starting at around $1,500 1981 or $4,000 in today's money, the 5150 was available with a monochrome or CGA graphics card, twin 160K floppy drives, and initially 16K of RAM. It featured Microsoft Basic in ROM and IBM PC-DOS 1.0 on floppy disk, a version of 86DOS initially licensed from Seattle Computer Products, and then taken under the collective wings of Microsoft and IBM, and co-developed into the MS-DOS and PC-DOS that would go on to dominate the IBM-compatible PC market until it was finally killed off, in the mainstream market at least, with Windows XP in 2001. It was certainly a good 30-year run, but I'm not really here to talk about the history of DOS and about the 5150 itself, a path that's been well trodden by people far more qualified than me. No, as I mentioned at the beginning of the video, I want to talk about my particular machine here, how I came to acquire it, what I did to get it up and running, and of course those upgrades that I mentioned. As you can see, the outside is all pretty standard stuff, with a 5153 CGA monitor, twin floppy drives, and that lovely tactile Model F buckling spring keyboard. But it's on the inside where things start to get interesting. So let's take a look. So this layout should look familiar to anyone who's taken the cover off of a PC before, but of course that had to start somewhere, and it started here. One thing that really struck me about this machine is how solid and well built it is, especially compared to cheap cases from the 90s and early 2000s that I've worked on in the past. A bit of a double-edged sword then, considering I imported this machine from the US. It survived the journey unscathed of course due to its tank-like build quality, but of course cost a fair bit in shipping due to the weight. The thing is, the UK had a well-established homegrown computer market in the 80s, and so PCs were a bit slower to catch on here, and by the time they did, local companies like Amstrad were churning them out much cheaper, so the IBM just didn't sell well at all, despite a huge number being manufactured in Scotland and Ireland. UK models hold their value very well in the collector's market, and with piles of these things taking up space in US recycling centres, sometimes importing is actually the cheaper option. Just be wary of the power supply voltage and use a step-down transformer, or gut the original PSU and fit something suitable inside. Speaking of that power supply, this one's physically bigger than what eventually became the AT standard, but the connectors are the same. This is the original 110V 63.5 watt unit, and I use it with a step-down transformer. It provides two 4-pin Molex connectors and the standard 2-part AT motherboard power connector. I'm sure you've spotted these two buttons here which aren't standard. They're part of one of my upgrades, and I'll get to those in a moment. On the front of the machine on this side there are two 5¼ inch floppy drives manufactured by Tandon. Mine do work, although to be honest I very rarely use them. They could probably do with a service actually. As this is a later machine, these are the TM100-2 drives, which are double-sided and have a capacity of 160K per side or 320K per disk. There are 5 expansion cards fitted, which I'll go over in a second. And down here is the 256K of RAM, which consists of 4 banks of 8 16-pin 4164 chips, which is the maximum this second revision motherboard can accept. When I got the machine it was refusing to boot and displaying a RAM error, which is why it was being sold for next to nothing. After some troubleshooting I narrowed it down to a couple of chips in the first soldered bank of RAM, so I desoldered the whole bank and replaced it with socketed chips. At the back here is a bit of a mess of power cables I've spliced together to power everything. I made this as a plug-in extension rather than modifying the original wiring. Another interesting thing I've added is this 5V breakout, which is used to power part of my video capture setup, which I'll show you now. So plugged into the graphics card via a 9-pin Y splitter cable is this device called a CGA2 RGB V2, made by GG Labs. It takes the 5V TTL signals used by the early IBM monitors and turns them into analog RGB signals, which I use with my video capture setup. Of course, it can also be used to hook this machine up to a more modern monitor, provided it can handle a 15 kHz input. It requires 5V to work, so I spliced in a power cable and ran it through a convenient hole in the back of the graphics card. I'll just get this wiring out of the way so we can get a better look in here. So in this slot I have an XT IDE, which is a modern IDE interface with a compact flash to IDE adapter plugged into that with a 512MB card, which is more than adequate for a machine of this age. It's about 20 times the size of a typical hard disk that would have been fitted back in the day, so that's plenty of space. Incidentally, I chose this over the more convenient type where you can remove the card through the backplate because it freed up some space for another little modification that I fitted, which I'll talk about in a second. Just before we get into that, I'll point out that we can now see the CPU, which is an NEC V20. This was originally an Intel 8088 when I got the machine, but I fitted this as it performs much better. Also, this one can be overclocked. There's also the 8087 FPU here, which isn't entirely necessary for my needs, but it fills a slot. This is a mass coprocessor that was only supported by a handful of professional software. I'll put a link to the page on my website where I've been compiling a list down in the description. Now you can see those AT power connectors a bit better, and below those there's a very interesting little overclocking mod that I had fabricated. I'll get some more bits out of the way before we have a look at that. So back onto this slot and the mysterious wiring connector I fitted here. This is actually a very basic circuit that taps into the PC speaker and turns the 5V square wave into something resembling a line level output, so I can capture that too. That just outputs to a standard 3.5mm socket, so it's very easy to hook up. Now we'll take a closer look at these expansion cards, starting with the floppy controller. This is the standard IBM floppy controller card which shipped with the machine. It supports 2 internal drives as well as an external unit via this big D-sub connector on the back. To be honest, I rarely use the floppy drives, but I like to keep it in here just for originality. The next card is the network card, and before I can pop that out I need to remove the AUI to Ethernet transceiver module on the back. So as you can see, this module has the familiar Ethernet port on one end, in this case 10BASE-T. This plugs straight into my gigabit switch with all my modern equipment with no issues at all. On the other end it has a 15-pin AUI or attachment unit interface connector, which is a standard that isn't around anymore of course, as modern cards have the Ethernet transceiver on board. The network card itself is a 3COM Etherlink 2. It has a socket on the back for an optional ROM, which this one doesn't have installed. As you can see, things like the IRQ and IO port are configured using these jumpers, as this card was very much pre-plug and play. On the back there's the coax connector, which is what the vast majority of those early networks would have used, and the aforementioned AUI connector. Next up is a very popular multifunction upgrade card made by AST called the 6-Pack Plus. Which reminds me, I really need to get the correct real-time clock battery for this. Anyway, in addition to the real-time clock, as you can see this card has some more of those 4164 RAM chips on board, for up to 384K in total. In conjunction with the 256K on the motherboard, this brings us to our maximum of 640K, which should be enough for anyone. This card also provides a 25-pin serial port, so it's a very useful thing in a system with a limited number of slots like this one. Finally, there's the graphics card. Oh, just before I take this out, I just want to point out how long this thing is. Earlier computer cases had these slots at the front to secure these longer cards, which were eventually phased out as things were miniaturised. So perhaps the most obvious thing about this IBM EGA card is the RAM expansion that's been fitted. It has 64K on board, but the fully populated expansion daughterboard adds a further 192K, which gives us the full range of resolutions and colours. Unfortunately, I only have the 5153 monitor, so I don't get to take advantage of those, but it's very rare for early games to use them anyway. Output is via a 9-pin D-sub connector, and the monitor type is configured using these dip switches on the back. When configured to use an IBM 5153, as mine is, it actually enables some enhanced graphics modes that basically allow EGA games to be used on a CGA monitor, which is very useful, as the 5154 EGA monitor is very rare. I'll demo some of those later in the video, and I also covered this setup in more detail in an earlier video, which I'll link up above and down below in the description. Incidentally, I was very lucky to find this card complete in its original box after having previously tracked down a CGA card, as well as the monochrome MDA card that came with this machine, which means I have the complete set. So with those cards out of the way, we can get a better look at the PC speaker and that DIY audio output circuit. These 5 62-pin connectors are what IBM referred to as the PC bus. Of course, you'll probably recognise them as 8-bit ISA slots, but the term ISA, or Industry Standard Architecture, didn't come along until later when IBM-compatible clone machines started to appear. So earlier I mentioned these two buttons. One of them is a momentary switch and the other is latching, and these are something that I added. I decided to mount them in the back so as not to change the look of the front of the machine, and I put them in this position above the power supply to make it easy to reach around and press them when sat in front of it. Those switches connect to this, a device called a PC Sprint, which is an early DIY overclocking solution designed by a chap called Doug Severson and shared in PC magazines and on BBS's back in 1985. It provides an additional Intel 8284A clock chip and crystal to provide a higher clock for the CPU, and plugs in place of the original 8284A. In my case, that's a 21.47 MHz crystal, giving a clock speed of 7.16 MHz, which is nearly 50% faster than the standard CPU clock of 4.77 MHz, and gives a really nice performance boost while still keeping things stable and usable. So to cut a long story short, the two buttons on the back of the case are turbo and reset buttons. Incidentally, I will demo this later in the video, but I also put together a more detailed video earlier this year about the PC Sprint and how it works, and I'll link that in the usual places. I'll also put a link to all of the other info I have on this mod down in the description. Finally, I just wanted to point out the dip switches on the motherboard. Things like graphics card type, amount of RAM installed, and the number of drives, which would later be configured in some kind of BIOS, are actually set by toggling these. Simple but effective, if you have the manual. So let's get this thing put back together and have a look at what it can do. So booting it up, we see the XT IDE BIOS, which auto-detects that compact flash card. It also has some basic features like swapping the floppy drives around and booting from other drives, and booting from ROM. There's also a very lightweight packet driver for the network card. The date and time are displayed. This is of course coming from the real-time clock on that 6-pack Plus card. I'm using a modified utility here that's Millennium compliant, so even on this old PC it's possible to set the correct year in 2020. Finally, you can see that I'm running PC-DOS 7 Revision 1, or PC-DOS 2000 as it's more commonly known. You may think that this is a bit of an odd choice for such an old machine, but the memory footprint is actually in the same ballpark as DOS 3.3, while providing lots of newer utilities and support for useful things like bigger partitions. Of course, it's also made by IBM, so seems very fitting for this machine. Incidentally, on the subject of memory footprint, I've been doing a lot of testing with various different DOS versions, and that testing's still ongoing, but I didn't want it to hold up this video. Hopefully I'll have some results soon and I'll put them up on my website as soon as I do, but for now you'll just have to take my word for it. What I can tell you is that if I run the checklist command, we're showing 585.104 of 655 bytes free, and that's with the network driver loaded. So far I haven't managed to run out of RAM with anything I've tried to run on this machine, and of course I can always disable that network card driver to free up a little bit more if I need to. There are some solutions to add more than the supposed upper limit of 640k RAM. In fact, the old school PC did a really great DOSember video on that I'll link to in the description. But to be honest, I have later machines for anything more demanding anyway, so it hasn't proven to be a problem. One thing that I just very quickly wanted to cover is my capture setup for this video. I'll be putting together a video all about video capture at some point in the near future, but I imagine I'll get a few questions about it like I usually do. For this PC, I'm using that CGA to RGB I showed in the teardown, hooked up to an OSSC in 4x line multiplying mode, which bumps up the resolution to 1280 by 960. I then capture this over HDMI with my StarTech USB 3 HD cap. As you can see, it gives a very clean picture. So, on to networking, and how I transfer files to and from this machine. I use a set of utilities called MTCP by Michael Bruckmann, which is a very lightweight free open source software networking suite for DOS that provides DHCP, FTP client and server, an HTTP server, Telnet and a few other useful things. It runs on an 8088 CPU, DOS 2.1 and as little as 96k of available memory, so it's absolutely ideal for this machine. So first I need to register myself on the network and get an IP address, which is as simple as running the DHCP command. Then I connect to a ProFTPD server running on my NAS. Once it's connected, I can browse around like any other command prompt. As a test, I'll copy over a game just to show how it works. Incidentally, Mr. Lurch showed a slightly more convenient approach in one of his DOSember videos, where he actually runs the FTP server on the machine itself. I didn't really think to do that when I set this up a few years back, but I'll probably change to that setup in future. So just before I copy the files, I'll switch into binary mode so the executables don't get messed up. And I'll also turn off prompting for individual files. And away we go. So I'll just check that those files have all copied over okay. And they all appear to be there, so let's just try and run this and we'll see what happens. And as you can see, that all seems to be loading just fine. Now, this is a good opportunity to show off one of two upgrades that I have in this machine that I think this game is really good for demoing. And the first one is that IBM EGA card. Now, obviously this is an IBM 5153 CGA monitor, but with the official IBM EGA card, you can actually set the dip switch settings so that it will display EGA graphics on a CGA monitor. So as you can see, we've got the lovely EGA title screen there. And of course that's really useful because these 5153 monitors are a lot more common and a lot less expensive than the much rarer 5154 EGA monitor. CGA basically only let developers use one of 4 predefined palettes of 4 colours from an overall palette of 16, while EGA gave them any 16 they wanted from a palette of 64, so it was a huge improvement. The reason it was possible to display some EGA modes on a CGA monitor is because they both use TTL for signalling, and EGA graphics modes 0DH and 0EH, or 13 and 14, actually ran at a resolution and refresh rate that CGA monitors could display, and it turns out that these are the modes that most EGA games at the time used anyway. It was just a case of graphics card manufacturers choosing to allow this, and in IBM's case at least, they did. In the later Commander Keen games, they actually managed to replicate John Carmack's groundbreaking EGA scrolling routines in CGA somehow, and that meant that there were actually CGA versions available, but I think playing them for any length of time would genuinely give me a migraine. Unfortunately, I just have no nostalgic love for the CGA colour palette. As it happens, the EGA version runs much better anyway, thanks to those aforementioned routines. Another personal favourite of mine is Prince of Persia, and this one's a completely different story. While the cutscenes look really nice in EGA, the game's actually much more playable in CGA as it runs a lot faster. The other upgrade I wanted to talk about is the PC Sprint, which is that DIY overclocking solution I mentioned earlier in the video. Now, for that to work, you need the higher clocked versions of the CPU and the FPU. So in my case, I have a 10 MHz capable NEC V20 CPU and the equivalent 8087 Mafco processor. In gameplay, the turbo mode makes a massive difference. For a start, speeding up loading times, Also in-game, it provides a very nice bump to the frame rate, meaning that some later 286 era games which would usually stutter are perfectly playable on this system. In the Checkit PC benchmarking tool, I get a 50 to 55% speed increase pretty much across the board in turbo mode, and that's on identical hardware. The performance of the V20 CPU is already better than the original 8088 it replaced. The PC Sprint was just a case of getting a PCB fabricated and populating it with around £6 worth of components. If you'd like to do just that, I'll link to the GitHub I created with all of the details down below in the description. Finally, I just wanted to talk a little bit about sound cards and why this machine doesn't have one. I actually have an Amstrad AdLib clone with a genuine OPL2 chip on it, as well as an OPL3 LPT parallel port device, and I've tried both of these on this computer, and to be honest they just slow the whole thing down to a crawl. I think the CPU overhead of pumping out that audio data is probably just a step too far for it, but to be honest I have a 486 that I use for some of those later games, so it's not been too much of a hardship. So I hope you enjoyed joining me to check out this PC. Now, as I mentioned at the beginning of the video, December 2020 is officially over now, and a lot of great creators have put a lot of work into some really fantastic DOS themed videos, which I'll link to down in the description, and I also urge you to check out the December hashtag. If you're interested in my EGA on CGA setup or my PC Sprint overclocking board, I've also put out 2 separate videos on those subjects, which I'll link to down in the description as always, and in my end card at the end of the video. So finally, I'd just like to thank you very much once again for joining me. If you enjoyed the video, please give it a like and hit that subscribe button, and I'll hopefully see you around.